I'm really sorry. I think there was a play button on the other side of things. Really sorry for the interruption. I take this opportunity to welcome Aarthi, and we thank her for giving us this opportunity to learn through her experiences. And with that, Aarthi, I'll let you take over the session. Thank you. Thanks for joining in. Yeah.
Thank you. Thanks, Janakya. I'm going to share my screen. Are you able to see the screen? Janakya? Yeah, you're able to see my screen, right? All right, I'll get started.
Yes. Yeah.
Thanks. Thanks, Chanakya and DeFi for giving me this opportunity. Hello, everyone. Wish you all a very happy new year. So this will be today's agenda. So we are going to look at why data visualization, what is the process, and also see how we can visualize it Tableau. And finally, we will cover some design principles. Before I move on, I just wanted to ensure that you all have installed Tableau Public in case you want to follow along. So go to this website, public.tableau.com, and you can give your email address and download it. From there, it is an easy step to install. Just follow the instructions. I will be covering a little bit of theory before moving on to the tool. So that should give you some time to install this in case you haven't. Why data visualization? I like this quote from John Tukey. The greatest value of a picture is when it forces us to notice what we never expected to see. Here, the emphasis on forces us to notice and what we never expected to see, right? Like, so data visualization has two purposes. One is to confirm our beliefs using data. So we have some assumptions or hypotheses, so we want to confirm it using data. Or it can surprise us by showing counterintuitive facts. Why data visualization? The human brain can process an entire image for as little as 13 milliseconds. About 80% of the information we take in is by the eye. The human brain processes visual 60,000 times faster than the words. Right? So there, according to a Forrester research, when we hear a piece of information, we remember 10% of it after 3 days. Whereas if you add a picture to it, you can remember almost 65%. So data visualization is not only the fastest way to show data, it's also a key factor in the impact and recollection factor. I'm going to time this. I'm going to give 30 seconds for you to understand which region has highest GDP in the year 1870 and 2003, which is a region that has the fastest growing GDP, and are there any peculiar trends in this? Now, what about now? Right? Like, so visualizing this, helps you understand. So, okay, so Western Europe has highest GDP in 1870, and USA has highest GDP in 2003. And both USA and Western Europe seems to have a fast GDP growing rate from 1870 to 2003. And another peculiar thing here is this orange line, which is China, right? From 1973 to 2003, there is a steep growth in China's GDP, right? So this actually takes like about like 5 to 10 seconds for you to understand all these patterns as compared to like the previous one I showed you, which is in a table, right? So this is why data visualization is important. And data visualization is used throughout the analytics maturity curve. So if you look at from reporting, basic reporting to the prescriptive analytics, data visualization is used everywhere. So in these steps, as an exploratory data analysis, data visualization is used in answering the questions, what happened, why did it happen, and what is happening now. And similarly, this paves as a foundation for doing your predictive, prescriptive, and forecasting. And even in the during the model and after the model building phase, also data visualization is useful. For example, during the model building, you can use data visualization for displaying feature importance. And similarly, after model visualization, you can use charts like area under the curve or confusion matrix to show the accuracy of the model. Data visualization is not a new field. It's been around for a long time. So some of the historians who have used data visualization ranges from like 1600 onwards. So I have like two things I wanted to show you so you understand. This is a picture of London, a particular place called Broad Street. In 1854, a cholera epidemic spread quickly throughout Soho in London. The broadsheet area had seen over 600 deaths, and physician John Snow plotted the location of cholera deaths on a map. So what you see here is a map, and these number of lines over here denotes the deaths. So he saw a clear concentration of these around water pumps. Uh, this was the time like when they did not know what was the reason behind the spread of cholera. One of his most fascinating discoveries was the relatively good health of 535 people who worked in a brewery. So you see the brewery over here, and then there were not many deaths around this place. So according to the foreman working there, the workers were allowed to drink as much of beer as they want during the work hours. So naturally, they did not drink and preferred beer. Due to which there were not many water spread cholera infection. So Snow found out that like there are some white flecks that keeps floating on these pumps, and that was causing the illness, right? Similarly, this one is by Charles Joseph Minard. He is a French civil engineer who is known for numerical visual representation of things. So his most famous work is the map of Napoleon's Russian campaign of 1812. So here the thickness of the line is how Napoleon marched towards Russia. So you see Moscow over here. And the thickness of the line while returning is the left, what was left over in his army, right? And then you see here the axis as the temperature. So you see somewhere between minus 18 degrees and like the temperature of the geographical places that they travel to, right? So visualization is not a new thing. It's been around for a long time, and now we have tools and we have like a process for data visualization. So the process in data visualization is shown in this slide. We start with a business objective or hypothesis. Let us say that we want to know some insights from our sales data. So we are running a company and we want to know some insights from the sales data, right? So the next step is to collect the right data to analyze this. This would be our sales register or sales data. So then we prepare the data, and then we look at some visuals, basic visualizations to understand like how the data is, etc. And let's say next you want to know how the customer view of things, right? Like so, then okay, now that you only have sales data, you go back and also collect the customer data, right? So this process from the data collection to the visualization is iterative. Depending on like what you find in this step, you go back and collect more data. But one key thing to remember here is to not deviate from the scope of your analysis, which is finding insights from your sales data. So the next is to like define key metrics and start visualizing the data to see any patterns. And yeah, so finally, once you have all the KPIs and your findings, you prepare the dashboard, and then you present the conclusion or your report to the board, right? So this is a typical data visualization process. Your data is only as good as your ability to understand and communicate it, which is why choosing the right visualization is essential. And before we move on to the data visualization, I'll take some time to do a quick recap on the data types and the scales of measurement. So we have two different data types. One is quantitative and another one is qualitative. So we call the quantitative measures and qualitative as dimensions in Tableau. The quantitative data can be split into discrete and continuous. So discrete is what can be counted but not measured. Like for example, number of children in a family. Continuous is what is being measured but cannot be counted. For example, height of the person. right? And categorical or qualitative data represents characteristics. Therefore, it can represent things like a person's gender, language, ethnicity, region, etc. Categorical data can also take a numerical value like 1 for female and 0 for male. But these numbers are purely for either like model building or using in further calculations. There is no mathematical meaning to these numbers. Scales of measurements. Nominal scale. So nominal value represents discrete units and are used to label variables that have no quantitative value. So for example, gender can be measured on a nominal scale. Ordinal data is an extension of nominal data, except in this case, you will have a ordered value. So it is therefore nearly the same as nominal data, but the ordering is important in this. You might have, submitted some survey where they ask you a range, they give you a range of options from strongly disagree to strongly agree. Like, how would you answer for this particular question? Usually, those things, those kind of qualitative answers where the rank has to be preserved, are measured on ordinal scale. Then we have interval. So interval are ordered units that have the same interval. They don't have a true zero. Example, a temperature scale. So the interval is the same. Zero in an interval scale means something. It doesn't mean like no value. It means also a kind of measure. So 0 Celsius or 0 Fahrenheit is also a measure. Next is a ratio scale. So comparison of absolute magnitudes. This can take 0. For example, number of units sold, a person's income, etc., can be measured in the ratio scale. Okay, visualization tool landscape. This is a magic quadrant by Gartner, released in 2020. So Power BI and Tableau, if you can like see here, are the leaders in this BI space. So today we will be looking at Tableau, but as much as possible, the visualization principles, the design principles are same. And they are tool agnostic. So today we will be covering Tableau, but you can do the same thing in Power BI or in any of the open source tools like Matplotlib or RShiny. Before we move on, are there any questions so far? Okay, so yeah, I take that as a no. So now let us move to Tableau Public. I hope you all have installed it. So this
Hi.
is the, yes, Chanakya.
Hi, Aarthi. So there is one question. Is it possible to vividly describe discrete and continuous data type? Yeah.
Sure, sure. Okay, so discrete and continuous, like I said, discrete is when you can count something. Like I said, number of children or the population size. These are all something that can be counted. So it is a discrete variable. Continuous is what can be measured. So discrete is mostly a whole number and cannot take negative values. Similarly, continuous. On contrast, continuous can take negative values, and it can also take decimals. So for example, the height can be measured as 125.5 centimeters, whereas in discrete you cannot like say number of employees in a company or number of children. All these are discrete. So yeah, so moving on, let us look at the Tableau interface. So this is how it looks when you open Tableau. So you have like the data that you can collect over here, and then your recent projects appear over here. So today we are going to look at COVID data. So I'll take a few minutes to show the data to you. So this is the date. We have the daily cases and deaths by country. So we have the date representation, week of the year, so which week it belongs to, anywhere between 1 to 52 or 53, number of cases in that week, number of deaths in that week, and then the country or territory, which country it is. This is for geocoding, for visualization. I'll show you how this works inside Tableau. It's just abbreviation for the country name. This is the population data of that country and which continent it belongs to: Asia, Africa, America, etc. And this one is a number of 14-day average for per 100,000 population. So this is the data we have. And if you look at it, it is a CSV data. It's a comma separated value. So in Tableau, we will look at it, we will import it as a text file. So when I click on this, it gives me option. So I'm going to import this. So you can see the columns that we saw in Excel over here as well. So as soon as you select the data, before you start making the visuals, Tableau shows a preview over here. So in case you want to like add another table or another data, so you can add from here another Excel file, whatever you want, and then you can drag and drop the table over here and make some joins. So we will only look at a single table and doing the basic visualizations today, but I just wanted to like show you there is a possibility. So we click on sheet 1. So here, so all the dimensions, right? The qualitative columns qualitative columns are shown here, and the hash that you see are usually for the numeric columns. So ABC is a string type. This globe icon you see, this is taking the feature of a geography, and then this the small calendar icon means this is a date column. So you can change the column type from string, data, number to whatever you want inside Tableau as well. So here you have like some options. We will see what this is when we start making the visuals. And then this show me is where like the chart types are. So what we will do is we will start with the basic bar graph. So if I go back, so bar charts are very versatile. So they are best used to show change over time, compare different categories, or compare like part of a whole. So if we want to like establish a ratio, say in our case, we want to look at the number of cases or number of deaths divided by the population. So then bar charts are the simple and best. So here, all you need to do is drag and drop. Let's say this is a continent. You either drag and drop here or over here in the rows. And then let's look at the cases which you drag and drop in the columns. So as soon as you drag and drop the columns, what Tableau does is it chooses the best visualization possible. So, and also here you will see some of them are grayed out, some of them are enabled in color. These color enabled graphs are the alternatives that you can use for the two columns that you have selected, right? And when you hover on these, beneath over here, you will also see what is required to create this chart. So for example, to create a bar chart, you required one measure, 0 or more dimensions. Similarly, for a line graph, you need one date, 0 or more dimensions, 1 or more measures. So this helps you to identify what charts or what data you need to use these charts. Over here, what you see is basic formatting. So you can click on this and like choose the color you want, that you want to like select, and you can also add more colors as per your need. And this denotes the size of the bar. So these are all basic formatting in Tableau. And then label is the data label. So when you select this, you will see the number displayed. And then tooltip. So tooltip is when you hover over a column or some part of your chart, it will display what have you selected over here. So what is selected here is America and a number of cases. So you can add, for example, number of deaths in the tooltip. So when you hover over here, you can like see only the number of cases in the bar, but you can see the deaths in the tooltip, or like over here. And so this is to add a new worksheet. So it's like adding a sheet in your Excel. And similarly here, you will see some of to add a new dashboard or story point. We will come to that later. And this is for if you want to duplicate a sheet. Say, for example, here you want to duplicate this, and then instead of the number of cases, you want to plot the number of deaths, right? Like, so you just override it like by dragging and dropping on that. So yeah, Tableau is that easy. This is for swapping, like, yeah, from vertical to horizontal. And this is for sorting. So you want to like sort on ascending or descending order. And this is like for highlighting in case you want to highlight. And yeah, this is just presentation mode if you don't want to look at any of that. So this is a basic view of Tableau. And what we have here is a simple bar graph. Right. Stacked bar. So stacked bar is like when you want to like add one more dimension and stack it. Like for example, so you have a monthly traffic by source, and the traffic comes from either email marketing, organic search, or paid search. So stacked is best used when there is a need to compare multiple part to whole relationship. So these can use discrete or continuous data oriented either vertically or horizontally. So in our case, let's say here, if we want to like create this into a stacked bar, so you have that option over here. So when you click on this, all the continents take up the color as another dimension and are represented as a single bar graph, right? So this is a stacked bar. Next is 100% stacked bar. Instead of looking at the absolute numbers, let's say you want to look at the proportion, right? So how much percentage of traffic comes from, let's say, email marketing or organic search, then you use a 100% stacked. Over here, how you can convert this is when you click on this small down arrow here, or down looking triangle, you can add some table calculations, right? Like you can add a running total, difference, etc. In this, we will select percentage of total. So basically what that does is, in this case, so total of America divided by the total number of cases, so which is 47.74 percentage. So this is 100%. If you look at it, the x-axis has changed to 100% from previously it was number. I'll show it one more time. Go to quick table calculation and click on percentage of total, right? Like, so 47.74 percentage of the COVID cases come from America, 16% from Asia, and 31% from Europe, right? So this is the basic bar chart and stacked bar chart. Let us look at like some best practices on these. Use only horizontal labels because people can read it faster when it is horizontal compared to diagonal or vertical. Space bars appropriately. So space between the bars should be at least half of the bar width. Are the y value always NCU, because by default we assume that the x-axis and y-axis starts at 0. So if you want to like truncate something, it's ideally not good. Avoid it as much as possible. Then use consistent colors. So use one color for all bar charts unless you're using the stacked bar chart. You may use an accent color to highlight a significant data point unless, color is a dimension to display the data, like I said in the stacked bar chart. And order data appropriately. So you can either order it alphabetically, sequentially, or take the value column, the measure column, to sort it in descending or ascending order. So for example, over here, if you look at it this way, so this right now is default sorted alphabetically on the continent name. And then you can go over here and then, you can sort it over here, which is also available next to your axis name over here. So this is ascending order and this is descending order. Right. So this is about bar graphs. Next, we will look at pie chart. So pie charts are best used for making part to whole comparisons with discrete or continuous data. Again, this is more impactful with a small set of data. In case, for example, let me show you the difference. Here, for a bar graph, you can add the countries, right? Like you can remove this. So for bar graphs, you can look at the country. You can sort it descending order. So United States, India, Brazil, Russia, France, these are like the top 5 countries having the highest number of COVID cases. But when you use a pie chart, it's better to like stick with like 5 to 6 to show the proportion. So the same thing that we showed in a stacked bar graph can also be shown as a pie. So pie and stacked bar chart can be interchangeably used depending upon yeah how it looks aesthetically or the point that you want to prove. So I'm going to add this to the sheet. Sorry, not this. I'll add the continents and then I'll add the cases and then the pie chart is enabled here. So let's look at it. Right, I'm going to show this for entire view and then display the labels, right? Like so here you see the angle and the size of the circle are based on the cases weekly. So here you have the legend. This is the color legend, and like when you select on it, yeah, it is Oceania is too small. The number of cases, right, which is in the proportion. Let's duplicate this, and in this, let us. Sorry, this is the death per week.
Aarthi.
Yeah.
Aarthi, hi. I think it got disconnected for a while, for 2 minutes or so.
Okay.
Yeah, we can probably rewind back a bit.
Sure. From where can I start? Can you help me
Uh,
with that?
yeah, I think we lost you at just 2 minutes back. Let me just check, keep up with this. Yeah, I think
Sure.
maybe like we can start from pie chart or something. Yeah,
Okay, okay, yeah, I'll redo from the pie chart onwards.
yeah, yeah.
So yeah, so pie charts are best used for part to whole comparison, and it can be used with either discrete or continuous data. So how we can do pie chart in Tableau is yeah, you can click on a new sheet. I'm going to add a continent, and I'm going to add number of cases. And when you click on the show me, the pie chart will already be enabled. So let's look at that. I'm going to blow up this to the entire view. And then I'm going to show data labels. So 26 million. And you can see the color legends over here. So 26 million cases from Europe, 18 million cases from Asia, etc. So here, this is not sorted right now. So you can like use the sorting button over here. So now it is sorted. You can add more information to the tooltip. So I'm going to drag and drop one more column on tooltip. and then I'm going to convert this into a percentage of total, so that when we click on this, we not only see the number 18 million from Asia, but we also see the percentage, which is 21 million. 21 million of the total world COVID cases come from Asia. So going back to the best practices, visualize no more than 5 categories per chart. So it is difficult to differentiate between small values. In our example, we saw that Oceania was a very small, so that was not visible in the pie chart at all. So depicting too many slices decreases the impact of the visualization. What we can do is, we can, in case we have more than 5 categories, we can show top 4, and then the remaining all categories can be grouped into either other or miscellaneous, unless there is something that is specific in those others you want to show. And in that case, it is better to use a bar graph. Don't use multiple pie charts for comparison. It is very difficult to compare like one pie chart to another pie chart on the angle of the chart or size of the pie. Always use a stacked bar chart. So in our case, if we, let's say, want to show side by side the number of cases and the number of deaths, what we can do is we can use the number of cases and show that as a stacked bar chart over here, and then convert it into a percentage of total. And then we can do the same again for the death. Percentage of total, and then enable labels. So if you look at it, in case of death, let's look at America. So 47.74% of the total COVID death in the world comes from America, whereas the 43.94% percentage of the total cases come from here. So if you compare, it's better to like compare these two simultaneously. I'll show this again when we cover the dashboard section. But if you want to compare two measures, it's better to do it in a stacked bar chart instead of a pie chart. Make sure, this is very important, at least in case of Tableau, this is taken care by Tableau itself. Make sure all data adds up to 100%. Of course, the proportion cannot, the sum of all the proportions cannot be more than 100%. Order slices correctly. So you can order it either clockwise or counterclockwise. Better stick to one, but make sure you order it so that the magnitude of the largest to the smallest or smallest to the largest is visible. For example, here, America, Europe, Asia, and then Africa, and then somewhere here you have Oceania as well, right? So this is about pie chart. Any questions so far? We have covered bar chart, stack bar chart, and pie chart as of now. Before I move on, if there are any questions, I would be happy to take it.
Yeah, I think so far there are no questions. There are few other questions which we can probably take it up later. But people are requesting if we can go a little slow, because I think they are also doing hands-on. But at the same time, I would probably suggest people to probably do the hands-on later on too and follow the session now. Yeah.
Okay, yeah, but nevertheless, I will slow down a bit.
Yeah,
Thanks,
sure,
John. Okay.
sure. Thanks. Yeah.
Okay, so the next one that we are going to look at is line chart. So line chart are always used only when you have a time dimension. So time series relationship are best shown in line chart. What we have noticed is people use line chart for some other dimension as well. Like for example, in our case, using line chart for displaying the difference between different continents is not acceptable. So line chart, always remember, comes with a time series relationship. So in our data, we have date as a column. So I'm adding a new sheet. So date, this is already in a date format, but in case your data is not in a date format, what you can do is you can convert the data type to date. So here you have like numeric decimal, numeric whole, date and time, date, and then text. String is text. So you can select, For example, if you want to convert it into a string, you can do that. So from date, it has gone back to ABC. So this way you can process your data within Tableau as well. Yeah, I'm going to add this to the sheet, and then I'm going to add number of cases. So by default, it groups it, if you look at it, for a year. And when I click show me over here, now the line graphs are enabled. Line graphs and area charts are enabled. So let us take this line graph. What you see on the screen is for year. So if you press this small plus button, you can increase the drill down. So now from here, it has gone to quarter. Then you can do it monthly, and then you can do it weekly until daily, right? So, and then you can use this small minus sign over here to roll up back to month and week, right? So here, let's look at the label. So this, yeah, we are only 10 days into January, but if you look at it, there is a peak in November and December. Since the COVID, the first wave started affecting the world in March to May, and the second wave, at least in Europe, is going on right now. So the peak is in November and December. So this is line graph. Again, here you can add one more dimension. Let's say you want to look at the continent now. You can drag and drop it in the color so that you will see different lines. So for example, yeah, if we click on Oceania, it's almost like flat, close to the x-axis. And then Europe, you look at the peak happened in November for Europe. Most of the countries went into a lockdown from November till still we are in a lockdown. So there is a decrease from November to December. And then Asia, yeah, so there was a peak in August and another one in November. And America, there was a peak in again August and in December, right? So this is how you can look at each of the line graphs for each of the continent. So going back to the presentation, best practices always include a zero baseline if possible. Although a line chart does not have to start at zero baseline, it be included if possible. So if relatively small fluctuations in data are meaningful, you may then truncate the scale to showcase these variances. So for example, here, maybe if we look only at Oceania, it might have a different trend, but because this is done in the same chart as let's say America or Europe, this graph over here is almost flatline. So in case you want to look at Oceanias, then you can do show view toolbar, and then what I'm going to do is I'm going to zoom in. So the mild increase in Oceania can also be seen. So now you don't see other countries, but you look at Oceania over here, and the peak for Oceania also was in August and November, right? So this you can do, and then when you click back on this, you can see the whole chart again. So what you do is right click and show view toolbar, and then you select this button, and then you can zoom in, and you can zoom further in so that you can see the trends of Oceania, right? So going back, you can restrict the axis if you want to show the mild changes, but as much as possible, please show zero as well. Do not plot more than 4 lines. So if you need to display more, break them into separate charts for better comparison. Use solid lines only. Do not use dotted lines or dash line. It is distracting. Label the lines directly. So this lets reader quickly identify lines and corresponding labels. This is an important point in case you're sharing a static image. But in case of Tableau, you have this tooltip which helps you when you hover over it to display what the line belongs to, right? So yeah. Use the right height. So plot all data points so that the line chart takes up approximately 2/3 of the y-axis to the total scale. Again, this point is taken care by Tableau. So if you look at the axis, this axis is automatically See, this is automatically determined. You can also do it. You can fix it in like say, okay, my chart should range only from this to this. But it is by default what Tableau does is that it calculates a number that is like some minus so and so percentage from the minimum value, and from the maximum value another percentage. So it's always better to leave it to automatic, unless you want to fix it, because you're creating multiple charts and you want to like show the difference, right? Again, here you have include zero as an option. This is also by default included. So how I got to this, let me show it one more time. You can right click on the axis and say edit axis. What you're seeing here is x-axis, sorry, y-axis. Similarly, you can do it for x-axis as well, right? So here, if you look at it, the automatic selection of time range is done by Tableau. This is for line graph. So going back to the presentation, area chart also is used for time series. This also has same usage as line chart. They can represent volume. So you use yeah. Instead of the line, the area beneath the line is shaded. And let me show how to do that in Tableau. Again, right click and add to sheet. I'm going to add cases of weekly, and then I'm adding this as well. And when I do that, automatically this area chart is selected. So I'm going to click on this, and sorry, this has been added twice. I'm removing one of them, and then I'm drilling down to the monthly level, right? So this is area chart, right? So best practices for area chart: make it easy to read. So in stacked area charts, arrange data to position categories with highly variable data on the top of the chart and low variable on the bottom. Again, this is taken care by Tableau. In our case, these are common best practices for visualization. So if the tool that you are using does not come with these facilities, these features, then you may have to pay attention to this. Start y-axis at 0. Don't display more than 4 data categories because of the color. Use transparent colors so that like the area behind is also visible. Don't use area charts to display discrete data. This is for continuous data. So here what you can do is, you can select the opacity so that the transparency is decided for your chart. This is for area. Now we are going to look at scatter plot. So scatter plot usually shows the relationship between two sets of quantitative variables. They are best used to show correlation in large amount of data. So scatter plot, both your x-axis and y-axis will have numeric data. So I'm going to add number of cases and number of death, right? So here, so the total number of world cases is 84 million, and total number of death it is 1.8 million. So the moment you add two numeric columns, Tableau automatically selects the scatter plot. Here you can add dimensions. Let's say we want to add continents. Let me drag and drop here, right? So the dimension that it has taken is shapes. So different shapes denote different continent. And in case you also want to add countries, I'm going to drag and drop it on color. I'm going to say add all members. So so here this is USA, and this is Asia, India, and then this is America. So there is naturally, so if you want to like add a trend line, I'm going to right click trend line. Oh, sorry. So this is so if you look at it, there is a correlation. If you draw a line on this, there is a correlation. So what you can do here is we can add a reference line, right? This reference line is the average number of death and average number of cases, right? So you have some on this side and some on the this side. Let's say we want to zoom in and view over here, right? Like, yeah. So you have some countries on the top right where the number of cases and the number of death are high. Bottom, this quadrant is number of cases and number of death is low. Here you have number of death are high but number of cases is low, so which means for the number of infected people the death rate is high. For example, Ecuador, Hungary, and Bolivia. Here number of cases are high but the death rate is low. So if you look at it, it is Bangladesh, Switzerland, Portugal, etc., Morocco, etc. So this is how sorry. So this is where you can use a scatter plot. You can probably compare where it belongs in like above average or below average, put them in a quadrant to understand, let's say, which countries are having a high death rate and high infection rate, etc. One more feature here, what you can do is you can add the continents to the filter, right? Add it to the filter. I'm going to like say show filter. So here, if I select, let's say only Asia, right? So you have Indonesia over here. Sorry, let me unselect this. Yeah. So this is India over here. And then you have Iran. And then you have Indonesia. And if you look at other countries, so you have, yeah, Iraq with a high death rate and high number of cases, Philippines, Bangladesh. So these are all on the high death and high number of cases. And these are all in the below average in number of cases and number of deaths, these countries. So you can select the continent and look at the scatter plot only for, let's say, particular continent, the number of countries in the particular continent, right? So this is about scatter plot. So again, always start y-axis at 0. Include more variables. So use size or dot color to encode additional data variables. So here, like I was telling you in the previous examples, like stick to 4 or 5 categories. But in comparison, in scatterplot, you can use a lot more. Use trend lines. These help draw correlation between the variables to show trends. Don't compare more than 2 trend lines because that becomes confusing. Yeah. Next is heat map. So heat map is when you use the shade of a color to show the intensity. So heat maps display categorical data using intensity of the color to represent values of geographic areas or tables. So going back, how we can create heat maps in Tableau, we can create 2 different kinds of heat maps. One is for the geography. Like I said here, the country and territory code automatically takes the geographic position. We can either use this or let me share view data over here. So the geo ID has been done on this column, whereas we can use this column also for the variables for geocoding. What I'm going to do over here is I'm going to right click and then geographic role. I'm going to call country. So this is the country that we have. And then I'm going to right click and add it to the sheet. So here you bottom right corner, you see something called one unknown. Whatever Tableau cannot plot, let's say you have like some spelling mistake or something in your data, you can say edit location. So this is the unrecognized. So what this is the cases on international conveyance. Okay, so this is the cruise ship that was initially quarantined because they had like a lot of COVID cases on board. So this doesn't represent any geographic. So what we will do is we will ignore that for now. And what you can say is you can filter out that data. So when you say filter that data, that gets filtered out. So wherever this thing is non-null values, only the lat and longitude with non-null values will be taken. How we will create heat map over here is we will take this shaded maps, okay, and then let's drag and drop the cases on the color. So this intensity, the darker the color is, the higher the COVID cases are. So maybe we can look at a different color. Sorry, what you can do is you can click on this small arrow over here and say edit colors. You have a lot of default options in Tableau itself. Let's say we want to use red because we want to show the intensity. Let's say okay. So USA is really dark, and then like India is like in the next option. Because USA is a exception, you see other colors are getting influenced by that. So USA, Brazil, India are the top three, and because of that, everything else are in the same shade, right? This doesn't give you any clear information. So what you can probably do here is you can add continent, sorry, not over here, to your filters. Show filter, and then you can like say single select, and then you can look at one at a time. So now we are looking only at Africa, right? So now the color has totally changed. So South Africa has 1.1 million, which is the highest, and then next looks like Morocco. So this is how you can select a particular country so that the outlier is not influencing your color of shade, right? Similarly in Europe, so Russia is influencing with 3.2 million. Next is I think United Kingdom and France, both at 2.6 million. All right. Here also you can narrow in and like see, let's say how many in Germany or Belgium or Netherlands, etc. Right. So this is an example of heat map using geography, using a map. Let's say we want to use tables, right? I'm going to add this and again add number of cases. So in this example, you see the dot size is influencing. So this is United States, in the top position, India and Brazil. So the size of the dot. Here I'm going to go and select this one, highlight tables, right? So you have a heat map like this, and when you sort it, you see the color represents the shade of the color. The darker it is, the higher the cases are, and then the lighter it is, the lower number of cases. Let's say in this you want to add one more dimension. Let's add date to it. So let's say you want to expand it, right? So now look at it. The cell color is shaded by the number of cases in a particular quarter. So this one takes the lowest value and the highest value. So if you look at it, lowest value is 0, highest value for the table is 12 million, right? So this way you can create a heat map in a table format. Previously we looked at it geography. Right, so the intensity, for example, in India happened in Q3 of 2020, whereas in US it is Q4 of 2020. So you can compare by quarter, by country, how the cases are. And like I showed you, let me show it again. You can edit colors and choose the colors you want. Okay. Going back to heat map, best practices. Use a simple map outline. So these lines are meant to frame the data, not to distract. Select colors appropriately. So some colors stand out more than the others, giving unnecessary weight to the data, like we saw how United States number are influencing. Instead, use a single color with varying shade or a spectrum between two analogous colors to show intensity. Also, remember to intuitively code color intensity according to values. Again, choose appropriate data ranges. Select 3 to 5 numerical ranges that enable fairly even distribution of data between them. So in this case, one more thing I want to show is in the edit colors, you can also use converging colors. So red and green converge. So in our case, we want the higher number to be red and the lower number to be green. So you can check reversed. So now when you apply it, like, yeah, so this one stands out. Maybe what you can also do here in the advanced option is you can decide what should be the start end and center point. Because of this 12 million outlier, you have the center point as 6 million. Instead, let's say you want to restrict it to 1 million, you can do that as well. So when I say apply, so yeah, so all the 1 millions and above will be in the shades of red, and 1 million, 0 to 1 million will be in the shade of green, right? So you can also use this converging colors to show the distinct reason. Like for example, if you look at it over here in Poland, right? So this Q4 has really high cases, right? Like 1.1 million. Previously, it used to be like 50,000. It has like almost doubled, and then now it is again in 61,000, right? So you can look at you can look at these distinct colors with the distinct observations with the converging colors, right? Like, so if you look at it, most of these countries have their second peak in the Q4. So the Q4 is in mostly red color, whereas others are in green. So depending upon, I have just chosen 1 million, but it is better to choose it scientifically. So depending upon the distribution, you can choose either median or average uh, point for the center point. Or like I said, you can use filter, and instead of putting all the countries together, you can create different charts for different continents. That is also possible. Any questions so far? We have covered almost all the chart types.
Right. Yeah. Aarti. So we have one question. Can you please show how to add a trend line to scattered plot? I think
Yeah,
you have explained few minutes back. I think yeah.
yeah. Right. So here you have this data section, and then you have this analytics section. So in this analytics section, you can drag and drop like a trend line, right? Okay. So in this case, it is adding a trend line for each of the edit trend lines. I'm going to unselect this and then like say okay. Oops. Yeah. So what I this column is average number of death in the world, average number of cases. This one, this column is average. Okay, I'm going to probably do it again from scratch. That's better. So I'm going to add cases weekly. I'm going to add death weekly. So it creates a scatter plot, and then I'm going to add these countries as a different colors, over here, right? And then I'm going to click on this analytics, and then I'm going to show the trend line, drag and drop, linear. It shows the correlation plot. So it also, when you click on this, gives you a p-value, r square, and then the equation. And then how I added the average is I right clicked and then added a reference line. So here I'm going to use average. You can also add minimum, maximum, etc. So this added an average depth, and this add a reference line, average, and this added a average number of cases weekly. So this average number of weekly cases is 395,000 that you see here. Average number of death weekly is 8,600, and this is the correlation plot. You have the r square value and the number of cases weekly and the relationship.
Got it. Yeah. Thanks. And
Perfect.
we have one more question. Can we apply Python notebook to Tabula?
Yes, you can. That we should probably like spend another day.
Yeah.
Of course, you can add R and Python code to Tableau. So basically, you can create your model in Python or R, and you can visualize that in Tableau. So that is a different case. But what I will do is I will share. There is a nice blog on how to do it. So probably after this session, I'll share it with you, Chanakya, and you can upload it to the DeFi portal.
Yeah, sure. Works. Thanks.
Okay, so whoever it is, thanks for asking the trend line question, because that's what we are going to look at right now. Is how do you find stories in your data? What kind of stories you can find, right? Like you can find trends, correlations and outliers. Right, like trend is when you find a relationship or some pattern over a period of time. So ice cream sales over time. Correlation is when there is a relation between two variables, which is ice cream sales versus temperature. And then outlier is when you want to identify a anomaly, right? For example, yeah, like ice cream sales are increasing in 0 degree temperature, right? So these are the things that you can find in your data. What are the relationships, right? Like nominal comparison. So this is a simple comparison of the quantitative values of subcategories. For example, number of visitors to various website. This and then time series. This is the line graph that we saw. So this track changes in values of a consistent metric over time. So number of COVID deaths over time, number of COVID cases over time, or the best time series that you will keep seeing is the stock market prices. So that is time series relationship. And then correlation, like we saw right now, the death and number of cases are correlated, highly correlated. So this is the data with two or more variables that may demonstrate a positive or negative correlation. So in our case, we saw a positive correlation, which means when one value increases, the other value also increases. Negative correlation is when one value decreases, the other value increases, right? So salaries according to education level, that's a positive relationship. Similarly, you can also have a negative correlation. Distribution, so this shows data distribution, how often around us, how data is distributed around a central value like mean, median, or mode. Height of players in a basketball team, right? Like, so in this case, maybe I'll take a minute here to go back to Tableau and show how to do a histogram there. What I'm going to do is add the cases and then click on the histogram. So here, yeah, 0 to 9,000. So this has automatically created the bins. So 0 to 9,000 cases, what you can do is, yeah. So it has, automatically created this. So I'm going to go here and edit. So this is suggested bin size. Instead of this, let's say you want to look at 5,000, right? Let's say, okay. So this is how your value is, like you see, thin lines. Okay, I'm going to show it by zooming in. Right. So here you have edited the bin size, right? Like, so first bin is 0 to 5,000, next is 5,000 to 10,000, and so on. So this is your histogram. So this is like a long tail distribution, which with maximum number of cases in the 0 to 5K. So this is how you create a histogram. So you take just one numeric value, and then when you click on this histogram, Tableau automatically creates the bin size, and it also creates a column over here. This column we never had. So you can right click, edit, and then you can decide the bin size, or you can like say suggested bin size, and it will automatically calculate it. Right. Okay. So that is distribution. Next is part to whole relationship. So this shows a subset of data compared to the larger or whole data. For example, percentage of customers purchasing a specific product. So you sell like some 3-4 products, and how many people are buying only one of those 4 products, right? Again, in our example, what I can show you is we have population over here. So you can create columns inside Tableau. So right click, create a calculated field. Okay, this is coming in my screen. Yeah. So what you can do is you can like say weekly cases. So here you see the weekly cases, and then you can say divided by population of that country, right? So this is let me say part, sorry, cases to population. Right? So this is how you create a column, and then the column is created. You will see a small equal to sign before that, which means these are the created columns and not that comes from the data. So let us look at countries and then look at cases to number of cases to population size, right? I'm going to put this in a table because that way it is viewed differently, better. Yeah. So Andorra, Montenegro have high cases to population percentage, right? Like compared to other countries, if you look at the absolute number, United States, India, Brazil, they're in the top three. But when you look at it as a percentage of population, the whole thing changes. So this is part to whole relationship. And then, of course, ranking, right? This shows how two or more values compare to each other in relative magnitude. So you can add ranks as well. So you can add, for example, from like the hottest month to the coldest month. This is also possible in Tableau. You can like add a rank. So you go quick table calculation and then you add a rank. So instead of showing the values of like 0.10 or 0.209 etc., now it shows the ranking, so 1, 2 and 3. So in the same way, if you want to like rank the number of cases, let me add countries and then cases. I'm going to show it as a table. And then over here, I'm going to use quick table calculation and use rank, right? So Afghanistan is in 91 rank or 88 rank. And like when I sort it, ascending, United States, India, Brazil, Russia are in like your first positions in the number of cases, right? So that is ranking. So these are all the things that you can find in your data, like trends, correlation and outliers. For outliers, I want to show you one more thing, which is box plot, right? I am going to add countries again and number of cases again, and like here it will allow me to use box plot, right? So here this is again United States, India and Brazil. Because it is in this way, you don't see the box over here. So what I'm going to do is I'm going to add continents, right? Like so now by continent you can look at the exception, right? Maybe I'll add it to filter and then show only one for now, which is Africa, right? Or maybe I'll show Oceania. Yeah, now you can see the box much more clearly. So in Oceania, Australia, and French Polynesia are exceptions, but other countries like Guam or New Zealand are not outliers. So these two countries are outliers. So similarly, you can select a particular country and then look at it. Here, Russia, United Kingdom and France, and then Italy are outliers. Okay, so this is how you can use a box plot within Tableau to identify outliers. Going back, so we saw the relationship. Now dashboard. So what I'm going to show is how you can create a dashboard, right? So I'm going to create a dashboard using this button, or you can go over here and say new dashboard. So here, oops, sorry. I'm going to like say automatic. So it comes here. I can just have to like drag and drop the sheets over here. So automatically you will see. So this is how you create a dashboard. You just drag and drop your charts that you have already created into a dashboard. But what I would suggest to do is, let's say if we want to create, which one is that? This one. Because this one was, yeah, number of weekly deaths. Yeah, this one is number of cases, right? Oops, I'm going to take this one. No range, automatic, right? So here you can format it, right? And then you can go to legend and like say show color legend. Yeah. Okay, so here you can like side by side compare. One is number of cases and the other one is number of deaths. So if you look at it like Asia, the number of death proportion is less, but the number of cases is high. right? Like whereas in Europe, the number of cases proportion and number of death proportion to the whole is the same. Yeah, in America, the number of death is higher than number of cases, and in Africa, it's almost similar. So what you need to do when you create a dashboard is you need to add the charts that are relevant to the story that you are telling. You need to create a particular point or a story point for your dashboard. Let's say in one of the dashboard, you want to take timeline, right? So you want to add only the time related aspects over there. So you want to first show the total number of cases worldwide, and then in another chart you want to like show the total number of cases by continent or country, and then in another dashboard you can use a theme which is only total number of cases, and in another chart in another dashboard you can create like 3 4 charts with let's say only total number of cases to the total population as a metric. So when you create a dashboard, all you need to do is to just drag and drop the chart, and then like your dashboard will be created. But you need to keep in mind to add those charts that are relevant to the story that you are trying to tell, right? So going back, dashboard design principle. So include text to explain your dashboard. So wherever it is possible, in case you're not physically presenting your dashboard, please always add text explaining the metrics that you have used, the formula that you have used. And if you have made any assumptions, please state that as well, because it is very important for the reader to understand that. Each dashboard should be constructed based on a story. Like I said, yeah, sales performance by multiple dimensions like month, author, genre, book, or territory, etc. So you can like decide what story are you going to say. And the story, again, remember, it's not a story that you are telling, it's the story that your data is saying. You just want to put those KPIs or the observations that you have made in a much more sensible manner, so that the user understands how the business is evolving or what you are trying to communicate. Do not clutter the dashboard. Always make sure there is enough white space and enough text to read and understand. Add filters on top of the dashboard. So when you add a filter, make sure it is applicable to all charts. Do not add a filter that is applicable only to one chart in a dashboard. That is very confusing for the readers. And then build interactions in the charts, or add filters only if necessary. This is a little bit advanced, adding interactions. For this purpose, I will share another article with Chanukya, and he will upload it in the DeFi side. Again, use color legends next to the charts if there are more than one. One of the beautiful things that Tableau does is when you use a particular column, it always assigns the same color if you use it in like a different chart as well. So for example, here, let me go to this sheet. So here, let me right click on the continent, and then here I can do default properties, which is the color, right? So I can like say what color each of these values in the column will take, so that wherever I use this column in my data, the same color legend is retained. So that instead of having in one chart the Asia in red color and in another chart the Asia in green color, it is very confusing for the audience, because the first time they come in understanding, okay, this color denotes this region, they always assume that it is that color that is throughout. So that is how our brain also fast process things, right? So you can like select different color palettes, and then you can like say assign palette, so randomly it will get assigned, or you can change it manually as well by clicking on this and then clicking on, let's say, a particular color, and then when you say apply, it gets applied. And automatically in the new sheet, let's say you are going to sorry, you're going to, let's say, sorry, not this, use a graph, and then use a bar graph, and then put it on the color. It uses the same color that you have assigned, purple for Africa, orange for America, etc. So this is a good practice, which is to like use the same color throughout, and only if there are different colors. So in this case, we have used just for continent. Instead, you want to use a color for the country, then show two different legends. But in this case, sorry, yeah, in this case, we have the same legend for both the charts, so it's okay if you just leave one legend over here. You don't have to put the legend again. So yeah, best practices: know your audience when you build. Limit the number of views and colors. Do not clutter. Again, add interactivity to encourage exploration. So when you add interaction to your chart, so the user, let's say, click on a particular portion, and then the remaining part changes. So they themselves discover the patterns. This is mostly important when you are, let's say, building BI dashboards that is periodically refreshed. Let's say you are building a sales dashboard, and you will build a reporting outline, and the patterns in that is usually derived by the user. Let's say you have some 10 sales managers for each region, north, south, etc. And then they themselves will look at their particular region data, and then they find the patterns. So encourage the exploration through interactivity. The users need to be able to interact. Test your dashboard before deploying. So please make sure that everything is working properly, the measurements and etc. Yeah, Tableau specific is consider the display size. You can adjust the font size in the data label, or you can adjust the pie size or bar size. So make sure that you understand that and create it well. Plan for fast load. So sometimes instead of connecting it to the whole data, if your data is too big, you can pre-process it in SQL or Python pandas, and then you can use only the processed file in this. You can already aggregate, create pivot tables in pandas or SQL, and then visualize only that table inside Tableau. But what you need to remember here is when you pre-process the data, the drillability is lost. So the ability to drill down to the lowest level is lost. So make sure your audience is okay with that. Leverage tooltips, so you can create a story within the story instead of cluttering everything on the chart. You can give more information only if it is needed. When the user hovers over a particular bar or a file, then they will be able to see further information. Some closing notes, which is do not do use one color to represent each category. Order data sets using logical hierarchy, alphabetical or ascending or descending for numeric value, etc. Highlight important or interesting information. So do not assume the audience will see it by themselves. You add a filter, you add a zoom in, and then like save it at that particular view so that the audience also sees that. Visualize data in a way that is easy for readers to compare values. Use icons to enhance comprehension and reduce unnecessary labeling. So instead of displaying the labels, you can have them as a legend. Don't use high contrast color unless it is absolutely necessary. So use a red and green or blue and yellow if you want to show a contrasting information. Like let's say you want to show a sales and sales returns. You can show sales in green and sales returns in red. Don't use 3D charts. They can skew perception of the visualization. Don't add chart junk. So unnecessary illustrations, drop downs, shadows, etc., or just ornaments, and it distracts the user. A simple bar graph is enough. You need to make sure that the message is conveyed than to clutter the chart area. Don't use more than 6 colors in a single layout. It becomes very difficult for the user. And also don't use distracting fonts or elements like italics or bold, etc. Some of the common mistakes to avoid: trying to answer too many questions within a single dashboard. Like I said, stick to either 3 or 4 charts in a single dashboard. If you want to answer more questions, like split it and put it in a different dashboard. And also you can add text to notify which questions are you answering in that particular dashboard. Use metrics no one understand. Make sure you're not complicating the metrics that you are using. Please use simple metrics like a proportion to whole or a percentage or percentage difference, etc. Yeah, cluttering the dashboard. I think I have emphasized enough on that. Yeah, not viewing your dashboard as your users will. You might want to convey something, but remember, you need to always put yourself in the shoes of your audience to understand what they want and how they want it, right? The best way to do this is to keep on talking to your business users to identify how they do it today. So for example, if they are doing it in an Excel file and they want to move to Tableau, you can first ask them, okay, when you were working in the Excel file, what kind of KPIs you were calculating, how were you viewing, what kind of pivot charts you created. Then understand the user's needs, and then you will be able to create it better in Tableau. Forgetting to check in with your audience, again, like the same point. Yeah, so what is wrong in this chat? Quiz time. Chanakya, I need your help because I'm not able to see the chat as well.
Hi, Aarthi. Is it audible?
Yeah, yeah.
Great, perfect. Yeah. So yeah, thanks. I think like we have a few questions. I'll
Mm-hmm.
probably pick some of them.
Sure, yeah.
Uh, yeah. So first is so this came in right at the beginning. What is the level of data visualization manipulation can be achieved in Tableau, like removing the clutter and other stuff?
Mm-hmm.
So
I'm not clear on the question. So,
So, what is the
manipulation.
level of data manipulation or data visualization manipulation can be achieved in Tabula? Let's say cleaning the data.
Oh, okay. So
Yeah.
cleaning the data. Okay, good question. I'm going to like create one more. So I want to show this. Sorry, not this. I want to show how you can create different columns, right? Like, so what you can do is you can say create a calculated field, and these are all the different functions that you have. You can do the same set of data processing that you do in your SQL or pandas inside Tableau itself. You want to like say convert a date column. Let's say your date uh, is in a different format, and you want to like calculate a date difference, right? Like difference between two dates, or you want to add a day of the week, day of the month or something like that. It's always possible. You can extract the year, you can extract the weekday or weekend, you can extract everything that you want from here, right? So you have many such functions, and the all the data pre-processing that you do in your SQL or pandas is possible here. But keep in mind, Tableau is a visualization tool. Though they have done like an amazing work in terms of pre-processing, they also have a separate tool called Tableau Prep, which does a good job of this data pre-processing. So make sure that you only calculate absolutely necessary things over here and not overload the tool so that it takes a long time to load when you share it with your audience.
Right. Got it. Yeah, thanks. And yeah, there is another question. What do you mean by deploying? And also, can you please discuss about how to share visualization?
Okay, so when I say deploying, there are various ways. The live deploying or something like that would be to host it on your company's portal, by using Tableau server, so that the visualization can be embedded. But to begin with, what you can do is you can save this as a TWBX file. Unfortunately, in Tableau Public, it's a free tool. They restrict few things. You can't import more than 1 million rows. And when you save it, it always saves it to a public cloud account. And from that cloud account, you can download it as a TWBX. So make sure when you are using Tableau Public, you are not using any proprietary data. Because the data gets published to the Tableau Public account. So I can probably like show you. So when I like save it, so it asks me like, let me say like book. So it is saving to the public account, and yeah. sorry, too many visuals to publish it. So what it is doing is it is I have signed in using my user ID. So what it does is it is saving to the cloud, and you can only see it as a web portal. If you open in my Chrome, just a second. Yeah. So this is my account, and this gets published over here, right? If I click on sheet one. So this is how you will be able to view it. You can download it as a Tableau workbook. And when you want to share it with your users, there is also another free tool called Tableau Reader. So you can download this TWBX file. So it will download current version or whatever, yeah, current version. And I say download. So it downloads a TWBX file, and this you can email it to the users, and they can use a tool called Tableau Reader. Let me show it to you. Tableau Reader is used only to read what you have prepared. It's think of it like a PDF viewer, right? Like you have a Adobe PDF viewer, like that. You can view the visuals in Tableau Reader. You can't do any kind of edit. So yeah, this is another tool which is like the same. So here you can only view your Tableau work, and not anything else. So the downloaded Tableau, if I say I want to go and open it, yeah, so all the sheets that I created are visible here, and I don't have any edit options. You can only like you go into a presentation mode and navigate between different sheets. So this is how you can share the Tableau file with your audience. In case your company has a proprietary Tableau desktop Tableau Professional, then you can save it as a TWBX file and share it with your audience, and they can use Reader to view it.
Right. Got it. Also, where can I practice data visualization? I have these, where, like, is there a platform which grades me and helps me with it?
Tableau
This
has some free videos from tutorial videos, so you can use that. And you have a lot of public data sets, like how I'm using COVID data now. You have data.gov.in, where India publishes their open data sets. Data.gov is US. So you have like a lot of public options there. So you can use this Tableau's tutorial. You just need to create an account, and your progress is also saved there. And you can use that, and you can actually like create there is nothing wrong in Tableau public, because it is also viewed as, so if I click on the gallery, a lot of people publishes their visualizations over here, right? Like you have biz of the day, featured, etc. So you can create a profile for yourself and showcase your learnings or the things that you create in your own profile gallery. So if I go about it, so my stuff can be viewed in my profile. So I think I have already shared the link with Chanukya, so he'll upload it. So you just use that web link to showcase your work. So you can also share that web link directly or embed it in your blog, so that people can view it on the analysis and the conclusions that you have made on the public data sets. You just need to keep in mind you use public data set or open data sets and not any proprietary while using Tableau public.
Yeah. Like, and apart from that, we have another question. What are the advantages of Tableau over MS Excel or Python? Basically the libraries like Matplotlib and Seaborn.
UI and like the amazing features that Tableau gives. Like I said, most of the best principles or the data visualization principles that I was telling you is already embedded in Tableau. Again, it doesn't need any coding. It's just simple drag and drop, and everything is GUI. So if you have already a fan of Excel, then like using Tableau is not a high learning curve as compared to Matplotlib or Bouquet plot or are shiny. So there the coding is high. Uh, Again, another thing in Tableau is the design. Like they have a very good sense of UI. Uh, so what you can create, what or the formatting options that they allow, the interaction options, these are all, if you have to do it in an open source code, it's a lot of coding. But in Tableau, it just is a drag and drop and GUI.
Got it. Understood. And is there a visualization expert in data science team, or is it a responsibility of one guy, one person to handle all stages of pipeline?
No, actually not. Like a good data science team will have a data engineer, a data visualization expert, and then a data scientist. Most of the time, the data scientist uses the output of a data visualization expert, or which is also sometimes is a data analyst. So they play around with the data, identify some patterns, or like identify insights from the data using data mining techniques or visual analytics, etc. And the data scientist uses that as an input in his feature engineering. So if you want to know how the data age is distributed, right, and like you create a bin based on that.
Right. Got it.
So yeah.
Yeah. Yeah. And someone was asking, like, how do you define the bins exactly?
So bins again, yeah, Tableau define it scientifically. The max minus min divided by the number of bins that you want. So this is like a size of the bin automatically suggested. Like I showed, you can also show the right bin size depending upon what you need, what you want to show. Because this 40,000 was like a high number. There was a lengthy tail to the distribution. But otherwise, what you can do is you can play around with it to identify how you want to show it. So you want to like show the 0 to 2000, you want to like show a lot of splits in the small categories, or you want to show it as a long tail. Totally depends. But if you don't know, it's better to go with the suggested bin size of Tableau.
Okay. Got it. And someone is asking, it's related to data cleaning again. How do you clean data like Power Query in Power BI?
So like I said, here you can exclude the missing values. You can create a new column, conditional column with if, to replace the blanks with missing with either like a standard constant or a mean or a median or something like that. So like how Power Query is for Power BI, this is also possible. You can like create if condition, else if, like, yeah, you have all those possible. So today I just wanted to show the basics of chart creation, but what is possible in Power Query is also possible in Tableau. And Tableau also has a separate tool called Tableau Prep, which focuses only on this data cleaning and data preparation. Unfortunately, that is a proprietary tool, but it also has a great UI where you can drag and drop the functions like missing value treatment or grouping or things like that, and you give parameters using GUI. But it has a 14-day trial, if I'm not wrong. So you can download it and play around with it.
Right. Got it. Understood. And yeah, I think we are pretty much done with my with our questions. I'll probably take one last question. So there is a question, one question on bar chart, multiple bar chart in single
Mhm.
sheet
Mhm.
are automatically spaced, or are they manually, or do we need to manually adjust them?
No, so by default, okay, let me show this. Yeah, okay, sorry. Let me click on the paragraph. Yeah, so this is optimal size. And like when I say entire view, Tableau decides this. So you will see like two dots over here. This one is when I said a standard. So this is something that you can use, that like hyphen that highlights in that is suggested by Tableau. Otherwise Tableau automatically calculates the bar size, etc., that looks aesthetically good for your visual. You don't have to think too much into that. I gave some points so that you remember if you are not using Tableau.
Great. Got it. Yeah. Thanks a lot, Aarthi. I think the session was very insightful, and it has kept the audience very engaged throughout. We can also
Sure.
see a lot of thanks pouring in there. Thanks a
Okay.
lot for sharing your.
I just have two things, two few things that I want to highlight. So maybe
Yeah.
if we don't have time, what is wrong in this chart is for the first 3 years they have used the year, and then after on it is Q1 to Q4. So this is not acceptable. Always you stick to the same measure.
Right.
Thankfully, in Tableau, all these things are not possible, so it takes care of by itself. And here, a line graph is used for a text column. Line graph should be used only for time series, date column. And again, the problem in this chart is the pi, the value doesn't add up to 100. So it goes beyond 100, which is not possible. Again,
Yeah.
what's wrong in this is too many colors, too many categories. So better to group it into five. Yeah, do not use this, instead use this. And yeah, I'm done.
Yeah, great. Thanks a lot for that.
My
And
pleasure.
also, yeah, thanks a lot to the moderators out there. I think we had Harsh, Jay, and Manish who were doing some amazing job. Thanks a ton, Aarti, for sharing your amazing learnings and also valuable time. And if you have
My
any
pleasure.
thoughts on I think you have already spoken about where they can practice and where they can find the data sets and all.
Yeah.
Also, I think Tableau also provides some videos, but if you have any other resources that you think that can be of help,
Hmm.
you can feel free to share. Or anyway, you're gonna share the blog links, right? I'll share it with them. But if you
Yes.
have any suggestions on the books or anything else, you can feel free to. Yeah,
Perfect. Yeah, yeah. I'll email it to them so that you can put it on the DeFi side.
yeah. Perfect. Thanks a lot.
Thank
Uh,
you. Thanks a lot.
yeah, take care.
Bye
Bye.
bye.